Hi, in this video we will employ the fabric nodes to make data rectangular. JSON format is an extremely lightweight and de facto the standard for exchanging data. The flexibility of JSON is beneficial when it's needed to transmit an order of invariable number of items, an online activity, or a response from a REST API. On the other hand, the versatility of JSON becomes problematic when one has to analyze a historical set of data or an online flow of messages. If one needs the data in a tabular form to ingest into a database, the nested JSON messages have to be denormalized. This slide shows an example of the nested JSON message. 3 denormalized JSON messages. And the table data. Fabric nodes are designed to compose and decompose nested structures to make dimensional transformations with no line of code. In this video we'll show how to connect to the source of events like Apache Kafka, Amazon SQS, or REST API. Consume nested messages having arrays of a variable number of elements. Extract elements from the arrays and make flat messages. Produce the flat messages to the destination of events like Apache Kafka, Amazon SQS, or REST API. The produced events can be consumed further and ingested into an analytical database or a spreadsheet. Try nodes. No code needed. Imagine, one has a flow of events having a timestamp, and an array of a variable number of key value pairs. The flow of events is published to the Confluent Cloud Platform to the array's topic. We'll employ the fabric nodes to connect to the event flow, consume the messages, decompose the arrays, extract the elements from the arrays, compose the flat messages, publish the messages back to the Confluent Cloud Platform to the item's topic. Let's get started. Welcome to Fabric.ai. The service is available for free for creating, testing, and sharing event processing scenarios. You need to authorize using email, Google or Facebook account. No card is needed. Click the editor link in the navigation bar to get started. Go to Node Editor. Create a new project. Name it Flatten Arrays to Elements. Click the project to start editing. You see a demo Hello World project. Click the Emulate button to get a welcome message. Delete the demo project. Call the menu and choose the actor. Rename the actor to Arrays Subscribe. Call the menu and choose the topic. Rename the topic to Arrays. Link the output port of the actor to the output topic. Call the menu and choose the actor again. Rename the actor to Arrays to Elements. Link the input topic and the input port of the actor. Call the menu and add one more topic. Rename the topic to Elements. Link the output port of the actor to the output topic. Call the menu and choose the actor again. Rename the actor to Elements Publish. Link the input topic and the input port of the actor. The actors are used to isolate the processing logic of node graphs. The topics collect results from the upstream actors and feed the downstream actors with messages. Now, let's dive into the processing logic. The actor contains the JSON in and the JSON out nodes by default. Delete the JSON in node. Call the menu and choose the Kafka read node. The node is used to connect to Apache Kafka topics and consume messages. The node requires to configure the API key, the API secret key, the group ID, the server sockets, and the topic name. The credentials can be found in Confluent Control Plane in the Cluster Overview API Key section. Click the Emulate button to consume messages from the array's topic. Watch the results. Save the sample message and return back to the project. Click the array's topic and upload the sample message. The message will be used to create ports automatically and test the processing logic. Choose the Array to Elements actor to dive into. Click the JSON in node. Click the Create Ports from Connected Topic button. The JSON in node reads the sample message, decomposes nested elements, defines data type, and creates output ports. Call the menu and choose the ArrayToElement node. Hide the unnamed empty port. The empty ports are used to transmit the entire message. Rearrange the ports. Link the output and the input array ports. Click the plus button to add a new input port. Name it timestamp and change the data type to integer. Link the output and the input ports. The ports are used to transmit the values on the element level. The ArrayToElement node gets an array to the input port, extracts its elements, transmits the values to the output element port. Call the menu and choose the decompose node. The node is used to extract the elements of the nested objects. Link the output element port with the unnamed input port. The name of the port is copied automatically. Click the output port, name it key and change the data type to string. Click the plus button to add a new output port. Click the output port, name it value and change the data type to integer. Choose the JSON-out node. Add 3 input ports, name the ports and choose the appropriate data type. The JSON-out node gets the values to the input ports, composes the message and sends the message to the output topic. Link the output ports of the upstream nodes with the input ports of the JSON-out node to transmit the values. The graph of nodes is completed. Click the Emulate button to test the graph. Watch the results. Return back to the project and choose the Elements Publish actor to dive into. Delete the JSON-out node. Call the menu and choose the Kafka write node. Link the nodes. The Kafka write node requires the additional configuration parameters. The configuration parameters are stored encrypted. Nobody has access to your credentials. Return back to the project. Click the Emulate button to connect to the Confluent Arrays topic, consume arrays messages, execute the processing logic, and publish the flat messages to the Confluent Elements topic. The project is done. Save the project and fix the version. Only saved and fixed versions can be deployed. Deploy the project. Reload the page to check the status. Open the Confluent control plane to watch the messages in the Elements topic. The messages are flat and can be easily ingested in an analytical database or used by a real-time application. Return back to the Fabric node editor. You can create, test, save, duplicate, deploy, or rename your own project. Watch the collection of the public projects to observe more cases. You can clone and reuse any public project. Propose your project to be public. What's next? Go to Fabric I. Register to the Fabric node editor. It's for free. Find the Flatten an ArrayToElements project in public. Clone and try the project by your own. Find more public projects to try. Read the blog posts with more cases. Contact us if you have any questions. Welcome to Fabric.